Okay, this is question 3 on the HL mock paper. This question is about microwaves, and you've got a little diagram here of some microwaves going through a single narrow slit and being detected at a receiver between A and B. And helpfully there's a little graph, and they want you to continue drawing the graph in the first part of the question. So on the axis below, sketch a graph to show the variation of intensity of the microwave radiation with distance along the line AB. And it's been started for you, you've just got to finish it off. So there's a few key points that we need to take into consideration. I've tried to annotate the graph to show us what they are. If you've read the mark scheme, then you'll have seen these as well. First of all, the slits need to be evenly spaced apart, but the spacing is important. So this blue line I've drawn is the width of your first central maxima. Each subsidiary maxima after that needs to be half that width. So these red lines I've tried to draw in the width of each subsidiary maxima. And you can see that the red line is half the width of the blue line. So that by eye, that needs to be quite accurate. Secondly, the height can only be at a maximum a quarter of the height of the central maxima. They decrease in intensity very, very quickly. So these maxima here should be very, very small compared to the central maxima. And finally, the areas of zero intensity or low intensity do need to be zero. They need to touch the bottom line. They need to touch the axis. So you get a mark for each one of those. Most candidates, this is from the examiner's report, most candidates did the general shape very well, but it was drawn far too rashly, it was too scruffy, and not enough of these points were really accurately shown. So the line didn't touch the bottom of didn't touch the axes, the widths weren't accurate, they were just the shapes that was drawn in, and that's not enough to get you all the marks. So that's how you get 3 marks in that question. The second question is about the width of the narrow slit. So what happens if you reduce that? Now, one of the answers you can take from the mark scheme, and the other one is a bit more common sense. But there are 2 main effects of the intensity. The first effect is from the mark scheme, and if you look at the mark scheme, there's this relationship where theta is proportional to 1 divided by the slit width. So if you decrease the slit width, then you increase the angle. And that's the first relationship. The second relationship is that if you decrease the slit width, then the pattern will be dimmer because fewer photons, fewer waves will be getting through. So there'll be less intensity reaching the screen. So that's just a kind of more common sense one. There were a couple more, but 90% of the answers were those 2 there. A lot of candidates as well misinterpreted this relationship here with the angle and the slit width. So just have a look at your formula booklets and double check that. Lastly, the standing waves are formed in, it's a completely different question. Standing waves are formed in microwave ovens. Why is that a good thing then, to rotate the food that's being cooked in a microwave? Most candidates got the answer that it heats the food evenly all the way around, but not many more consistently correct answers than that were provided. So first of all, we talk about why the food would or wouldn't be heated with standing waves. And we know that a standing wave has areas of maximum intensity and also areas of minimum intensity, or nodes where there's zero intensity. And at those nodes of zero intensity, the food wouldn't get heated because there's no vibration there. So you want the food to move through those nodes and back into regions of variable power to even out the heating. The OWTTE means of all words to that effect. So although most people got one of these marks, they evens out the heating, the rest of the marks weren't very commonly awarded there. And that is question 3.